Hi, Haley. Did you get my message last night?
Yeah, I got it.
Okay. All right, good.
I
Um,
printed off the quiz. But yesterday the Moodle site was doing something weird. Like it when I went to go to the Moodle,
uh-huh.
it would say sorry and all this stuff, so it wouldn't let me do it. And then this morning I finally figured that out, so I went to
Okay.
do it and print it off. So
That's
I'll
weird.
I'll
Okay.
have that back to you today.
Okay. No problem. I'm gonna just go ahead and send it to me. I'm gonna go over it too. So, uh, okay. Okay, you got Tori, Jennifer's here, Bree's here. Okay. Right. Guys, we're waiting. Excuse me. Wait a few minutes until everybody comes in to make sort of general announcements. Does anybody have any questions? I'm gonna sort of reassess today and talk about where we are and what we're gonna do for the rest of the period time, and talk about maybe grades a little bit and this, that, and the other. Okay. All right. I just got, who did I get in? Michelle. I got Michelle. I got Haley. I got Bree. Tori. Okay. All right. No questions? All right. Let me share the screen while I'm waiting for everybody to come in, and then we'll start going over some things. All right. Let's get that out. Let's see what we got here. Yeah, there we go. Okay. I forgot to wish everybody a happy Cinco de Mayo yesterday. What I did was go to the grocery store, buy a bag of chips and a big jar of queso, forget the salsa, and I ate about half the jar of the cheese with about half the chips. So that was not as much fun as Cinco de Mayo should be. I should have had a tequila in a restaurant with somebody or a whatever. Anyway, um, it's a day I look forward to, but this year was sort of weird. All those Mexican restaurants were thinking, "Oh my God, this is our biggest day of the year," and things are on the downhill here. Anyway, so let's take a look at that antiderivatives quiz while we're waiting for people to come in. Guys, I have posted this on. It's the thing I graded and tried to get back to you last night. It's posted on Moodle. But there people did have some errors on this thing, so I want to make sure everybody understands what we're doing and so forth. And I didn't even simplify most of them, but just to show you what the process is. That first one, when you have a function that's separated by pluses and minuses, you can do them individually. Now, I don't mean do them over to the side individually. Basically, I mean do them individually and string them all together. Okay, so when you use the power rule for antiderivatives here, it's 3x cubed over 3. This will be minus 6x squared over 2. The antiderivative of a constant is that constant times x. So essentially what you're looking at here, guys, is that it's 1 times x. Okay. So if that had been a 3, it would be 3x. If it had been minus 6, it would have been minus 6x. That kind of thing right there. You can always check. Your antiderivatives. See, this one, if I simplified it, would have been x cubed. That one would have been 3x squared. That one would have been 1x plus c. You can always check by taking the derivative and making sure you got back where you started to. It's an antiderivative, okay? You're given a derivative, you're asked to find the function. You want to check it? Take the derivative. Okay, I got somebody trying to get in. Stephanie's trying to get in. Okay. All right. Okay, she's still waiting. All right. So questions, anybody about that? There we go. She's in. Okay. So Stephanie, I'm going over the antiderivatives quiz right now, okay? You can hear me. Okay, so that one was easy. I didn't have to rewrite anything. It was all just nice powers of x. So I used that thing that said I can use that power rule that says add 1 and put it over that. Now, it doesn't work for x to the minus 1, but that's the only thing it doesn't work for. And I you didn't have to use that on here. Some of you thought you did because you made an algebra error. In the second one, x to the 5th over 7, that's 1/7. Don't bring the 7 up. The 7 is just that's a fraction there. So it's just 1/7. You can leave it in or pull it out. Use the power rule on that. It'll be x to the 6 over 6. And then the 7 times 6 is the 42. Always add your plus c at the end. We're going to talk more about that today. There is one more quiz I want you to look at. And it's the one where you're trying to find c given a point. In number 3, you got to rewrite. It's got to be a power that's up in the numerator. It can't be in a denominator. So how do you write powers that are in the denominator? You bring them up and they become negative powers. That's where you're going. I did that wrong. That's bad. Hang on a second, guys. This thing right here. All of a sudden I saw it. That's actually 5 over x to the 3/2. That also means I graded it wrong because I kind of talked about it yesterday and everybody wrote what I wrote down. Okay, but it's x to the 3/2. It'll because it's the square root of x cubed, not the cube root of x squared. Rats. I'll get it all.
On the test or the quiz, it was the cube root of x squared.
Oh, was it? So I copied the problem wrong. All right, let me get. Fortunately, this nice little pad will let me unmistake things. Okay, so thank you, Haley, for telling me that. So it really looked like this. It really should have been this thing right here. This thing right here should have been the cube root of x squared, and then
that's how it was on the.
Okay.
And it was also plus 9.
Jeez, what was I looking at? I don't
know. It was that plus 9.
Down below. Oh, this thing plus 9. You're right. It was. I remember that now.
Yeah.
Okay. Thank you. I just kind of looked completely wrong at that one. Forget it right there. So here's what the problem was. Okay. So I bring it up. It's 5x to the minus 2/3. Plus, that since this thing was plus 9 here, this last piece would have been 9x. Remember what I said happened when it was a constant, so I add plus c. When I add minus 2/3 to 1, I get 1/3. Down here, I get 1/3 in the denominator. When I invert and multiply, that'll give me 15 there. And then it's got the plus 9x with it. I'll just put it right here. Usually we put the c at the end, but since I copied the problem wrong, there it is right there. By the way, guys, when you're doing 3 at a time here, you only need one plus c. I mean, the reason for that is if you add 3 c's, you still get a c. You get a constant. If it's 2 and 3 and 5, when you add that, you still get some constant. So it's just an arbitrary constant. You only need to write it once. Okay. There was some confusion about 4 and 5. Since we're taking an antiderivative, guys, if we had a product, you'd have to be undoing some kind of product rule kind of thing here. We don't have anything like that. All we have is a string of things with pluses and minuses in it. We do not have any plus times here. So what we need to do to use the rule we have, multiply it out, and then deal with it like the other ones. So this one will be 2x cubed over 3. And this will be 2x to the 4th over 4. Okay, so that's what we get in that one. Same thing with a division. It's a lot harder to undo a quotient because it's a lot harder to differentiate a quotient. So you don't want a quotient here. You want to play it out if you can. Now here's where the algebra came in. This is a common denominator. X squared over x, 2x over x. X squared is x times x over x. One of the x's cancels and you get an x. Some of you made an algebra error there and I couldn't quite figure out what was going on. But anyway, x squared over 1x is just a single x. 2x over x is 2 when I take the antiderivative or the integral. Guys, I keep calling it the antiderivative because I'm trying to emphasize what you're doing. You're taking something whose derivative you know, you're anti-differentiating it to find out what the function is. This will be x to the 1st over 2, x to the 1 plus 1, which will be x squared over 1 plus 1, which is 2. And the integral of any constant is that constant times x. So there's that one. So if you see a multiplication or a division, you need to divide it out or multiply it out before you start. This last one right here, 3x to the minus 8, you got to write that up as a negative power. Your power rule only works when it's up here. It cannot be in a denominator. If I add 1 to minus 8, I don't get minus 9. I get minus 7. minus 8 plus 1 is minus 7. So this one was 3x to the minus 7 over minus 7. Okay. Now, so that's that. Any question about it? That still?
I have a question.
Yeah, Stephanie.
And I may have just missed it, but on problem 3, negative 2/3 came when we moved it up, right?
Yes.
Okay.
Because it was just, look, you just rewrite it. First of all, sometimes you have to, if I had like 6 over x to the 5th, I would write 6x to the minus 5. But sometimes if it's a radical, you have to rewrite the radical and then move it up. That's what happened there. Okay.
Yeah, that's okay.
Yeah, you had to do 2 things there basically. Okay. Yeah. Anybody else? Anybody? Another question? All right. Let me go back to again, my light. I can't scan with my light on, and I turn it off, and I can't see with it off. Hang on, let me turn my light on. Okay, there we go. So I want to look at. I don't want to look at Math 210. I want to look at Math 70. So so guys, a couple of things that I've done here. I have made a sample test. I've still got a couple of things I want to talk about today, but tomorrow I will not be talking about anything new. So you need to look at your homework tonight and then start kind of going through that sample test. And I literally wrote it like a test, okay? So the kinds of things you're gonna see on that, so you'll know sort of what to look for, what you're trying to do, the formulas you need to look for, and so on. So it's on Moodle. So I would suggest that you spend some time on that tonight, because we're going to look at it pretty closely tomorrow. The other thing that I wanted to talk about here, let's see if I can find it. And I already did this. Let's see if I've got several lectures here that I don't know if I've finished them or not. Let me look at this one because it's a good example of doing things when I have to do things a couple of times. What this says is, and this is the subject of the last quiz we're going to have, okay? And it's on there. It says it's the one where we find out what the C is, okay? And it's the very last quiz on there. And I'd like for you to work on that tonight and basically try to get it to me if you can. Otherwise, have it in front of you, okay? We're again at the point where we're past the 10 quizzes that I'm going to average, but any extra quiz you add can replace a low grade or a missed quiz. So, you know.
Wait, which one is it again?
It says antiderivatives and I can't remember, definite integrals, I think. It says antiderivatives.
Applications?
Say that again?
It's the applications one?
Gosh.
It says applications of antiderivatives
yes.
and definite integrals.
Yes, yeah.
Okay.
I hid one of them that, well, I tell you what, let me look at it later. I'll have to open up another computer to look at it without losing everything I've got right here. But we'll do that. I'll look at it and I'll let you know exactly which one it is. And this is
turn it in again.
Turn it in. See if you can do that one and send it to me tonight so I can look at what you've done. I'll tell you what, if you send it to me tonight, no matter what you do, if you've given it an effort, I will give you a 10 on it, okay? So everybody try it so I can see what you know, okay? Just get it to me tonight. I'll look at it. I'll mark it. Everybody will get a 10 on it regardless, okay? That a deal? Does that sound okay? Hope
Yeah.
So. Okay. So.
Yes, that works.
All right. So I'll let you know for sure which one it is. I'll look at it, make sure everything's okay on it. It's a problem sort of like this, where here we're given a second derivative, and we're told that it goes through the function I'm looking for, goes through that point, and we're also told that the derivative at 1 is 2. So it goes through the point 1, 0, and the slope of the tangent line to the curve at 1 is 2. But here's my question. I'm asking you to find f of x. Now, you are 2 derivatives away here from a second derivative. So you have got to anti-differentiate twice. Now I'm going to put this one on here because it'll show you how to do things a couple of times. So for example here, if that's the second derivative right there, and I want to find the first derivative, I will anti-differentiate 5, okay? Because that'll get me back 1. So what is the antiderivative of 5, guys?
5x plus c.
Yep, 5x plus c. Now, here's where I stop, and I say, okay, the function that we've got so far is f prime of x equal 5x plus c. Now, I am going to use this little piece of information here to figure out what c is, because it says if I plug 1 into the derivative, I should get 2. So, in other words, f prime of 1, plug 1 into the derivative, plus c, I should get 2. That's all that says. If you plug 1 into this derivative you found here, you should get 2. Now you can find c. If you solve for c there, you get c equal minus 3. All right, so here's the thing. I am halfway back. I have made it back to the first derivative, and I started with the second. So the first derivative is 5x minus 3. Now, you can check it. Certainly the derivative, that's the first derivative. The second derivative would be the derivative of that, and it's 5. You got half credit for this point, this problem so far. I was trying to get back to f. What I'm going to do is take one more antiderivative. If I want to find f of x, I need to take one more antiderivative. So 5x minus 3 dx. That'll be 5x squared over 2 minus 3x plus c again. I generated another c. Every time I anti-differentiate, I generate another c. But if you look at this other condition right here, it says if I plug 1 into the function, I should get 0. So I'm going to do that. If I plug 1 into this function right here, I'll get 5 halves, 1 squared, minus 3 times 1 plus c, and it said I should get 0. If I plug in 1, I get 0, so that's 5 halves minus 3 plus c equals 0. Minus 5 halves minus 6 halves is minus a half. That's a 0 right there. 0. So add these two together, I get minus a half plus c equals 0. So that says c is a half. So what I found is a function, f of x, now, which is this function right here, 5x squared over 2 minus 3x plus a half. If you differentiate it twice, you'll get back to 5. If you differentiate it once, you'll get back to, the 2's will cancel, you'll get back to 5x minus 3. Derivative of a half is a 0. And it goes through the point I gave you, and its derivative is right at that point. So this is just like 2 problems in one. And one of the problems on the test tonight is just, on that quiz tonight, is just do this one time. If you got the derivative, try to get back to the antiderivative, and I'll give you a point it goes through. You plug it in to find c. Okay. The problem you'll have tonight will look somewhat like this. If you're given f prime, find f, knowing that it goes through the point 1, 2. That's f of 1 equal 2, so you'll find an antiderivative. F of x, the antiderivative of this thing would be 2x squared over 2 minus 2x plus c. Then you plug in your 1, you set it equal to 2. So I'll have, this will cancel here, it'll be 1 squared minus 2 times 1 plus c should be 2. So plug in x, you should get that y. Here you'll get 1 minus 2 minus 1 plus c equal 2. So that says c equal 3. C equal 3. Did I lose somebody or did somebody try to get in? I just heard the doorbell ring.
So f of x will be?
F of x will be x squared minus 2x plus 3. Yeah, somebody's trying to get back in.
Okay.
Got somebody, wait. That's Bree. Okay. Okay. All right, I think I got Bree back in. Bree, that internet service in Eastern North Carolina, not real great. That's what I find. Okay, question, anybody? Okay, so let me look at one other thing here. We got another thing I want to look at. It was sort of what I was going to talk about yesterday that I didn't that I didn't get to. But let's go back and look at something else here. Find it.
But tomorrow we're not learning anything new, right? We're just going to go over the sample test.
That's a true statement. That's a true statement. Okay. So guys, one other thing, here's another application, and it's also, I think there's one like this on the quiz. It's exactly the same thing I talked about a minute ago. If you look at this, it says if the marginal cost of producing X units of a product is given by C prime of X is 32 minus 0.04 X, and it costs $50 to produce 1 unit. It costs $50 to produce 1 unit. Then find the cost function and find the cost of producing 200 units. All right, so let's do this one. This is a problem that's in the context, the same problem we just did a minute ago, but it's in the context of a business problem. So remember, guys, that marginal cost is C prime. So if I want to find C, all I have to do is anti-differentiate that. So 0.04. No, wrong. I got the 0.04 in the wrong spot. Here's the thing I'm trying to anti-differentiate, because that's a derivative, and I want to go back to the cost function. So it'll be 32 minus 0.04x dx. That'll give me the cost function. Okay. So when I anti-differentiate this, what's the antiderivative of 32, guys? What's the antiderivative of 32? It's just a constant. What is it?
32x plus c.
No, well, yeah, plus the c, and I'll put the c on at the end, but you're right, Stephanie, it's 32x. The antiderivative of this one is 0.04. That's the first power, so it's going to be x squared over 2, and then I'm going to add the plus c at the end. I don't need but one of them, so I'm going to add that. So I'm going to get rid of this problem. I'm not going to do it anyway, so whatever. Okay. So what that says now is that the cost function I'm looking for is 32x. Divide 2 into this will be 0.02 x squared. So it's minus 0.02 x squared plus a constant. Now that constant, that stands for, that's not cost. That's not the same C this is, it's just some constant. Now, here's how I find that constant. It says it costs $50 to produce 1 unit. That says then if you plug, it costs $50 to produce 1 unit. So if I put in my 1 for X, 1 squared plus C, I should be able to find out what C is. Okay, and then I'll write the equation. I'm going to subtract, now let's do this, guys. This is 32 minus 0.02, so 50 equal 32 minus 0.02 plus C. That's 50 equal 32 minus 0.02 is 31.98, I believe. So C is 50 minus 31.98. And I think that is 18.02. 18.02. Good. You might want to check me on the calculator. But what that tells, and again, I'm sort of working over all these problems. I'll get rid of that in a minute. But so what I found out is that the cost function, having found C, is 32x minus 0.02 x squared plus 18.02. I used that 1 point they gave me right there. The cost of producing 1 unit was $50. I plugged it in, and that allowed me to find the C. There's my cost function. Now, you can do anything you want to with it. What I asked you to do was find the cost of producing 200 units. So if I want to find the cost of producing 200 units, it'll be 32 times 200. minus 0.02 times 200 squared plus 18.02. Oh, shucks. Dyslexia here. Let's get rid of it. Okay. And then whatever that is, you can calculate that. Okay. So you got to find the cost function. Because you were given marginal cost, which is a derivative, you got to take an antiderivative to go backwards. Now, guys, if you look at that one, this one right here that I just marked through, it's the same thing with profit. Find the profit function if P prime of X is this, and P of 5 is 650. You got to take the antiderivative to find P, put that point in to find C. That's all you have to do. That's all you have to do. Question about that? What a marked up mess. But anyway, that's what it looks like. Okay. All right. There's one other thing I want to show you. That's sort of an application here. If I can find it. If I can't, I'll just write it up. Boy, I got a lot of stuff here. Let's see. Derivatives, assignment sheet, concavity. Nothing that I'm looking for though. All right. That's all right. I'll just start up with a new sheet here. I'll go down this way, and I'll just go here and look at some blank sheets. Now, there is one other thing I want to talk to you about, and it's something called a definite integral. A definite integral. Now, I'll tell you that I've got this written up somewhere, but apparently my lecture didn't load up, or either I put it in the wrong place. I'll probably show up in a different course later. But I'll tell you the section this is in, and I'll tell you where it is, and it's actually pretty easy to do. So, and then it's got a nice application. So that'll be sort of the last thing we do there. If you look at blah 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 blah. This is what was for the homework last night. If you're looking for where the problems are, it's in section 5.4. Okay, section 5.4, and is that one I want? Sorry for the problem here. Okay, yeah, 5.4. So, on page 340. Okay, on page 340, there's a definition that says this. It says the integral from A to B of a function f of x dx is equal to f of b, capital F of b, minus capital F of a, where f is an antiderivative. Capital F is an antiderivative. Now, the heading on that is something called the fundamental theorem of calculus. Okay, so the fundamental theorem of calculus. Now, the only thing that's different from what you're used to seeing is that I don't have just this integral sign anymore. I have these, F is an antiderivative, so this lazy S right here still means you need to take an antiderivative of that thing. But you've got these two things right here, this B and this A that you didn't see before. Those things are called the limits of integration. The limits of integration. With the one on top being called the upper limit, and the one on the bottom is the lower limit. Okay? What this says to do, and you don't know what it does or what it means yet, but it's easy to do. It says to take the antiderivative and then plug in the upper limit first, and then subtract the antiderivative with A plugged into it. So let me give you an example. It's actually easy. So it's just a matter of one more step of plugging things in. Suppose I said, let's find the definite integral from 1 to 2 of, let's see, 3x squared minus 2x dx. Okay? First step here is just find the antiderivative. All right, so guys, the antiderivative of that I picked kind of an easy one. It's easy to find. The antiderivative will just be 3. So find antiderivative. All right, find the antiderivative, which will be 3x cubed over 3 minus 2x squared over 2, and you're used to putting a plus c, so we'll put a plus c. Now, the question then is, what do I do with this 1 and 2? Well, one thing that I like to do is once I've taken the antiderivative, I'll put a bracket over here and I'll put 1 and 2 there because I don't want to forget that I've got something to do with those, okay? What this fundamental theorem of calculus said is, since this is the antiderivative right here, what you found, it says plug in the upper limit first and then plug in the lower limit and subtract everything. So I'm going to do that. And actually, I'm going to simplify it first because it's really, those two, that stuff will go. That's nice. I'll just make one more step in here. So you find the antiderivative, and the second step is plug in the limits. Plug in the limits. So here's what I'm going to do. I'm going to rewrite it. So minus x squared plus c from 1 to 2. All right, I'm going to plug in 2. 2 cubed minus 2 squared plus c. I'll put parentheses around everything. If you don't put parentheses, you're going to mess it up, okay? Because here's why. I put the upper limit in first, so I literally just chunk that in there. And c is just a constant, so it stays a constant. Then I'm going to take away the bottom limit plugged in. So that'll be 1 cubed minus 1 squared plus c. Okay, so if you know how to take an antiderivative, you can take a what we call a definite integral. Because it has these limits, it's called a definite integral instead of an indefinite integral. And here's why, guys. When I play this out, I'll get 8 minus 4 plus c minus 1 cubed minus a minus here. Oops, I didn't plug in my 1. I want to plug in my 1 there. All right, minus a minus will be plus 1 and then minus c. Okay, now look at this thing. Since you added plus c on the both ends, what's always going to happen to the c? I mean, in the first one it got added, and then in the second one it got what? What happens to it?
They'll cancel.
They cancel. Guys, I will tell you this, and I don't want you to forget that when you don't have these limits, you need to put your plus c. But when you have the limits, the c's are always just going to drop out. You don't even need to put it in there. Honestly, I don't care if you do. It'll always drop out if you get your signs right. But the number here is 4. Those two drop out. The answer is 4. The value of this definite integral is 4. So steps again. First step, find the antiderivative. So first step, find the antiderivative, which is what I did right there. And I said, since you plug it in, the next step is to plug in the limits. Top limit first. Top first. Then subtract off the bottom. The c always cancels. You don't have to put it in there. It has a value. So the question is, what the heck does that value mean? Let me show you a couple of things that are really kind of amazing that this thing means. Does everybody understand the process? Find the antiderivative, plug in the upper limit, and then subtract off the lower limit plugged in. All right, suppose I had this thing. I'm going to draw you a picture here. Then we'll practice another one of these things. Suppose I had the line f of x equal 2x. goes through points like 1, 2, 2, 4, and so on. Now, suppose I drew, see, that's 1, that's 2, it starts at 0. Suppose I drew a line down through 2. And what I see there in between that line, that is that I've formed a triangle, guys. See that triangle right there? Okay, so the triangle is formed between 0 and 2, and the hypotenuse on that triangle is always this curve for whatever point. Now, I want you to think geometry. Think back to grade 9 or grade 10. What's the area of a triangle, guys? Do you remember what the area of a triangle is? Anybody?
Base times height.
That's the area of a rectangle. You're almost there, though. The area of a triangle is like half a rectangle, so it's actually 1/2 base times height. Okay? Everybody with me? It's 1/2 base times height. So the area of this triangle, if this is the base, how long is that base right there, guys? Just looking at it.
2.
2. My picture is not to scale, but what's that? How far is it up here to the point 24? Again, it's not, well, see, it's 4 units, isn't it? Because that's the Y value, isn't it? It's 4.
Oh, yeah.
Yeah. Guys, my line should have had a lot steeper slope. It actually looks like it has a slope of 1, but it actually had a slope of 2. I should have gone up there a little further. But anyway, that's that triangle. So the height on the triangle is 4, the base is 2, so it's going to be 1/2. Base is 2, height's 4. I get 4 right there. Okay. Now, let me show you something that's kind of amazing to me, and it should be amazing to you as well, and I'm going to give you an example. If I said, let's find the integral, the definite integral from 0 to 2 of this function right here, 2x. Now, I want you to keep in mind that what I just did, the curve here, that was, wait a minute, the curve right here, that thing right there was your 2x. And I was trying to find the area of the triangle from 0 to 2. I'm going to show you that I will get that area by looking at this definite integral. So first step, guys, what's the antiderivative of 2x? What's the antiderivative of 2x?
X squared.
Just x squared. And you know what I said? I said, I don't even want to put the plus c, because the next thing I'm going to do is just plug these limits in. Okay? So I took the antiderivative, I take the limits, and when I plug in the upper limit first, it'll be 2 squared minus the lower limit is 0, plug it in, 0 squared. See, I'm plugging those into that, and I get 4. That's 4 square units. The fundamental theorem of calculus makes this connection between area under a curve and the integral, this definite integral. And you say, well, why do I need that? I mean, I could have found that area of that triangle using, if I remembered it, I could find it using this formula, no problem. Well, here's why it's important. What if I had something that looked like this? I'm gonna draw another curve. There's the curve, y equal x squared plus 1. Okay. And if I look x equal 1, that would be the point 1, 2. You plug in 1 to that, you get 2. If you plug in 2, you'll get 2 squared, you'll get 5. You get 2, 5. Now, here's what I'm interested in right here. I'm interested right now in finding this area right in here. Now, I'm going to say a couple of things about this area right here. Number one, it's no triangle anymore. It's not even the kind of geometric figure y'all are used to dealing with because it doesn't have a straight side here. It's got this side that's the curve y equal x squared plus 1. But the remarkable thing about this fundamental theorem, it says I can find the area of that irregular region by taking this definite integral from 1 to 2, wherever I've got it shaded, if I say the region from 1 to 2, and then under the curve. And the curve was x squared plus 1. So if you want to find area, it's bounded off on the left and the right by these vertical lines, and it's the area under the curve. I could talk to you theoretically about why it's true, but it's so close to the end of the semester, I just don't think I want to confuse you with it. It's not real confusing, but I would need longer to talk about it. But let's just do it. This one you have to take my word for. This is the thing Dr. Young and I joke about. We're going to Math Hell because we didn't tell them why it works. It just works, okay? I need to find an antiderivative. Tell me what the antiderivative of x squared plus 1 is. Anybody? What's the first one? What's the antiderivative of x squared?
2x.
No, you went in the wrong direction.
I'm sorry.
It's
X
squared over 2.
cubed over 3.
X cubed over 3. Look, guys, this is yeah, and then plus the 1x. Yeah, that's the antiderivative formula. Stephanie, you were in a car and you were trying to go backwards, but you put it in forward and you hit something. Okay, so I was trying to go backwards. Okay, an antiderivative, and then I'll put 1 and 2 up there. Everybody with me? I'm just taking an antiderivative, and the antiderivative of 1 is just 1x. Remember, if it's just a constant, it's just that thing times x. Now I'm going to plug in the upper limit, which will be 2 cubed over 3 plus 1 times 2. And I'm going to subtract, and because it's multiple termed, if I don't get those parentheses around it, I'm going to mess up the signs. Please, please, anytime you put a subtraction on something, put a parenthesis there, okay? So I'm going to put in 1. That'll be 1 cubed over 3 plus 1 times 1. So guys, what I'm doing is I'm plugging in these limits here. I plugged in 2, that was the upper limit, and then I subtracted off the lower limit plugged in. That's all I did. Now I'm going to crank it out. It'll be 8/3 plus 2 minus 1/3 minus 1. Get your calculator out if you want to, but leave it in fractions. I'm going to leave it in fractions. That's 7/3 plus 1. So I added those two together. 2 minus 1 is 1. 3/3. That's 10/3. Because that's 3/3. That's 3 1/3. If we're talking about area, that would be in square units. So what that says is even though this was some weird irregular area, its area is 3 1/3 square units. That's what this thing does for me. It's a definite integral. Now, part of the homework that would have been assigned for last night, you need to just look one back from what it actually says, and it'll have you figuring out these things, and it'll have you looking at some area. Why do I need area sometimes? Here's why I need it. It also measures what we call net change in a function. It measures net change. So for example, suppose I have a profit function right here. And I want to know how the profits changed from, say, 100 units to 200 units. Basically, what I'm finding is what the profits are here minus there. And what you'll be looking at is a marginal, a P prime. So suppose I've been told that profit is changing, P prime of X is equal to, I don't know if this is going to make any physical sense or not, 100 minus X. That's the rate of change of the profit. If I want to know how the profit changed, how did profit change? Whoops, going from 10 units to 20 units. Well, you know what? To figure that out, I would have to find a profit function. Well, I don't have the profit function. I have the derivative of the profit function. What do I need to do? I need to find the antiderivative. So the profit will be the antiderivative. All right. And if I did put 100 minus x in there, I'd get 100x minus x squared over 2. But look at what happens. So there's my profit function. I took an antiderivative because I had a derivative. I took an antiderivative, I've got profit. If I want to know how it changes going from 10 to 20, if I had a profit function, I'd plug in 20 first, then I'd plug in 10, and then I'd subtract. Well, that's exactly what this thing does for you. It says, okay, you want to know how the profit changes from 10 to 20? Find the profit function, then evaluate it from 10 to 20. It's called net change, and that's all it is. It's area and it's net change. So I'll finish this one out. We did this, it'll be 100. Again, we might come up with negative profit, but we could pretend we were a restaurant. So 100 times 20 minus 20 squared over 2. That's the first thing. I plugged in the 20. I plug in that upper limit first. Okay. Oops. So in other words, this 20 right here is what's going right there into your profit function. And then I'm going to take away, I'm going to put my parentheses in so I don't miss my signs. And then I'm going to plug 10 in. Okay, so that's going to be 100 times the 10 minus 10 squared over 2. So I plug the lower limit in next. When I compute that, I'll get 2,000. Let's see what I get here. 2,000. 20 squared is 400. So that's 2 into 400 is 200. Minus, that's going to be 1,000. 100 divided by 2 is 50. And then I just do the arithmetic. 2,000 minus 200 minus 1,000 plus 50. 2,000 minus 1,000 is 1,000. So I got that. Minus 200 plus 50 is 800 plus 50. So my profit changed by $850 or millions of dollars or whatever when I went from 10 units to 20 units. And that's what we call net change. So that's what this definite integral is about. On your sample test, I don't think I gave you per se an area problem. I did give you one of these things to compute. And on that quiz tonight, there's one of these definite integrals to compute. But I think on your sample test, I gave you one of these, I gave you one like this. I gave you this, this net change, and it may have actually been in profit, net change in profit. But you just take an integral, all right? And you know what? I wrote something wrong. Did I say from 10 to 20 units? That should not, I meant from 10 to 20 units. So I think I probably said 100 to begin with, but 10 to 20 is what I did. Okay. So again, tonight, guys, so here's what I'm trying to do. Tomorrow's Thursday. Tonight, I'm done. Well, let me ask you something here. I don't want to back myself into a grading corner. And I want you to know what you're making before next week. I've got 3 days with you guys next week, and I do not intend to cover any more new material, okay? I want you to have some time to work on this review sheet and this last assignment. So what I'm thinking, I don't know. I was going to give you the test. I was going to post the test. Here's what I'll do. I'll do sort of what I did last time, and I hope this will work out with everybody's schedule. I'm going to do total review tomorrow, okay? Look at this last stuff. Look at the big review. Look at the sample test. That's how I labeled it, sample test. And we'll spend the time we need to spend on that tomorrow. We will also take Friday at this time. You know, I hesitate to do that because it's not your class time, but this is optional. And we'll go over, if you got more questions that need to be answered, we can do that Friday. I will give you the test. I will post the test late Friday afternoon. It will be due, we will not have class Monday. That'll give us a little bit of a breather. I'll have your test back to you by Tuesday. I'll have your averages done by Tuesday. I'll have your averages done by Tuesday, and I will, we'll talk individually about what what we're going to do, whether you want to take a final or whether you want to take the grade you've got or whatever. Because the final's optional unless you want it to replace a lower test grade, assuming you make higher on the final.
So if the test will be given to us on Friday, is it due on Monday?
I will have it. What I will do, I want you to have your averages done by Tuesday. So I'm going to say we won't have class Monday. So let's just say by 5 o'clock Monday, okay? That way you'll have class time to work on it and whatever. And that way I'll have time to grade it Monday night and go over it and make sure everybody understands on Tuesday. And on Wednesday, it'll just be a catch-all day, whatever questions you have to ask me, whatever, okay? I'll write that down in an email, guys, because not everybody's here. But let me remind myself one more time of what I said. Tonight, do this new stuff. It's the homework that was from last night on there because I got a day behind. Look at the sample test. Do as much as you can on the sample test. At least look at everything and say, I think I know what I would do with that. I think I know what I would do with that. We'll talk about it tomorrow, and if you need to, we'll talk about it again on Friday. And then I will post the test late Friday. It will not be due until Monday at 5. Okay, I think that's what I said. Does anybody have any questions with that? Anybody issues or anything I need to know? Okay, I can talk to everybody individually if you come up with a problem you don't understand and you haven't started your test yet or whatever, or even if, whatever. You can send me an email and I'll arrange to have a Zoom meeting with you if you want to, individually, either about your grade or whatever, once I get all this done. Are we okay? All right, yeah. I'm gonna see you again tomorrow. Work on that sample test and work on this little bit of stuff about area and this net change stuff. All right, I'll talk to you tomorrow. Bye-bye.